Welcome back. In this video, I'm going to talk about FRC parts and how you can use them in Inventor. So in here, I have a list of certain parts, and the first part I want to talk about is stock. And stock is metal, and it can act as the structure or the skeleton of your robot. This is 1x2 stock, which means that it's 1 inch wide, 2 inches high, and it's 24 inches long. And there's other types of stock, such as 1x1 stock, which looks like this. And you'll notice that they have these holes which we can use to assemble everything. So let's say I wanted to make some sort of mechanism. I'm going to create an assembly, and let's place my 1x2 stock. But let's say, because the stock is currently 24 inches long, I needed it to be, say, 15 inches. Well, what I would do is I would go into my File Explorer, and I would make a copy of my 1x2 stock. And this copy, I'll rename it to 15 inches instead of 24. And now if I open it, obviously it's still 24 inches. And the way I can cut it down is by creating a sketch. And I create the sketch on the front face of the stock right here. And now I can draw a rectangle of any size as long as it completely covers the stock, just like this. And I'm going to finish sketch, and now I can intrude my rectangle so it cuts into the stock. So I need this stock to be 15 inches, so I'm going to have to intrude 9 inches. 24 minus 15. And as we can see, the stock is now 15 inches. So I'm going to save this. And let's say we need another piece of stock that's 10 inches. So I'm going to repeat the exact same process. I'm going to make a copy and rename it to 10 inches. I'm going to open it, start a sketch, create a rectangle that completely covers the front, intrude the rectangle. This time I'm going to intrude it 14 inches because I want it to be 10 inches long at the end. And as we can see, it's 10 inches long. I'm going to save that. And now I'm going to place my stocks into this assembly. Now, let's say we wanted to connect these stocks so that we can form a frame of some kind. For that, we need gussets. So I'm going to place a gusset, and a gusset serves the purpose of connecting pieces of stock. There are different types of gussets. This one is a 90-degree gusset, because this angle right here is 90 degrees. And using this, we can connect our two pieces of stock together. And the way we do that is by constraining this face to this face. I'm going to make the tops even, so they're lined up. And I'm going to make the sides even. And now I'm going to place my gusset on top so it connects like that. So I'm going to select this face and constrain it to these faces right here. And now I'm going to take this corner hole right here, and that would constrain to this corner hole here. So just like that. And I'm going to do one more constraint of these two holes right here. And now our stocks are fully connected. So I'm going to repeat the same thing on the other side. So I'm going to line up my stocks, constrain the faces so they touch, and now line up the tops. Now I'm going to take a copy of my gusset, and I'm going to constrain this face to this face right here, And next, constrain the corner holes. So that corner hole corresponds to this one right here. And just so the gussets don't pivot, I'm going to constrain these two holes right here. And in most cases, you would want to, in all cases actually, you would want to do this on the underside of the assembly as well. So you'd also put gussets right here and here. I'm not going to do that though because I don't want to be repetitive. So now let's say we want to have an axle running between the stocks. Generally we use hex shafts, and a hex shaft looks like this. So you can see that there are 6 sides to the hex shaft, and this shaft is currently 19 inches. So that's definitely too long for our mechanism, because this distance right here is only 10 inches. So if I want this axle to run completely across the stocks and maybe stick out 1 inch on each end, I'm going to need this axle to be 12 inches long in total. So I'm going to delete that, and I'm going to do the same process for cutting stock with the axle. I'm going to copy the axle. I'm going to rename it so it's 12 inches. I'm going to open it, and now the exact same process, starting a sketch on the front face, create a rectangle over the face, intrude the rectangle. This time it's going to intrude 7 inches to go from 19 inches to 12 inches. And I'm going to check that. 12 inches, perfect. So now I'm going to place this axle once again here. And the way we get this axle to run between these stocks is that we need to make a hole in the stock. And in that hole we will put a bearing. As you will see, I'm going to place a bearing. So we're going to make a hole in the stock, we're going to put the bearing in the hole, and then the axle will run through the bearings. So for the hole needs to be a diameter of 1.125 inches. So what we're going to do is we're going to start a sketch right on the face of the stock. Or actually, we should do this in the stock part instead. So I'm going to open this stock part. And now I'm going to start a sketch. And I'm going to create a circle right here of 1.125 inches. Yeah. And I'm going to want this circle to be, say, let's say 1.5 inches from the edge. So I'm going to use my dimension tool and just go like that. And now I can intrude the hole, so we have a hole in our stock, just like this. And because these two parts are the same, there's holes in both of the stocks, and it goes all the way through. So I'm going to save this. And now obviously this axle isn't going to fit in these holes, because this is a hexagon and this is a circle. And that's why we have bearings. Bearings also help reduce friction and stuff like that. So I'm going to place my bearings. This is a flange hex bearing. A flange refers to this lip right here. So I'm going to place my bearings in this hole by constraining the circular axes first. And right now this is the wrong way around, so I'm going to flip it. And now that they're aligned like that, I can constrain the flange part, the lip, right to this face right here. And now I'm going to repeat that process on all 4 of the holes. So I'm going to go like that, constrain the face to the lip, do that 2 more times. So right now the lip is on the wrong side. We're going to have to flip that using a different solution. And I'm going to constrain the faces again. And one more time. Just like that. And now you'll notice that the inside of these bearings are hexagonal. There are 6 sides, so they are perfect for our shafts right here. And the way you constrain these hexagons is by constraining one side at a time, and you'll need to constrain 2 sides. So I'm taking this side and constraining it to this side right here. And now I'm going to take this side and constrain it to its corresponding side. Right. Okay, it's hard for me to get an angle, so I'm going to need to move this. I'm going to take this side and constrain it to, I believe it is this side. It is not that side. And this is the pain with constraining these hexagons. It was that side. So now this hexagon is, or this shaft is fully inside and constrained to the bearings. And as I said earlier, there would be 1 inch of space on both sides of the stock for the axle. And we can lock this axle completely in place by using an offset constraint. So we can flush this face to this face, just like that. And we know we want there to be 1 inch of space. So we're going to need to make this -1. Because if it was just 1, it goes in the wrong direction. So this is -1. And now we have 1 inch of axle on both sides. And the way now in real life, we can't constrain it with an offset like that. We need to use something called lock collars. And a lock collar looks like this. And there's a tiny screw in a lock collar right here, and you can tighten it. So we're going to place this lock collar around our axle using the same hex constraining techniques as we did with the bearing. And this can get very, very tedious. Working with axles is not very fun. So now that it's on the axle fully, I'm going to constrain the faces of the bearing to the lock collar. So I'm going to take the same lock collar and repeat the process on the other side to add an extra level of security to our axles. So I'm going to constrain that side and let's say the bottom left of the axle. And just like that. Working with axles like this can get very tedious, especially when everything is black. So it is quite annoying at times. But now we have this axle running across our 2 stocks, and it's fully locked in place. Everything is locked in place. Now one thing is missing for this axle, and that is wheels. So let's place some wheels. I will place these flex wheels, and a flex wheel is a wheel, but it's rubbery and very squishy, and they're useful to add a bit of give to an intake mechanism, for example. In CAD, though, they can get quite tedious because their squishy properties don't necessarily correlate well. And another thing when we're working with wheels and axles is we need to use spacers. So what a spacer does is, obviously this axle isn't going to be just a complete block of like 30 wheels. We're going to have gaps in between the wheels. And this axle, which has a hex interior, will help us create that gap. So I'm going to constrain this wheel to the axle the same way we've been constraining everything else on the axle. So I can see because that didn't snap preview, it's the wrong side, so I'm going to click 2 again. Still the wrong side. Still the wrong side. Okay, I'm having some hex troubles, so I'm going to open relationships. These are the sides that are constrained, so I'm going to take this side then, and this side. There we go. And now because of previews, I know it's the correct constraint. So I'm going to bring this wheel all the way to the end here, just like that. And let's say I want it to be 2 wheels at a time, so I'm just going to create a copy of this and repeat the exact same process again. Hopefully it works this time. It does not. Yeah, as I've said before, working with hex in axles is very, very tedious. Let's try these sides. There we go. And I'm going to constrain these two together like that. And you'll notice that these are uneven, and that's just because of the flex that I talked about before. There is a way to get them so they look even and lined up, but it's very, very tedious. Would not recommend. So now let's say I wanted a gap between the next set of wheels. I'm going to add in this spacer to the axle. So just like that. Right there. And now I'm going to constrain these faces over here. And constrain the next pair of wheels. And I'm only going to add one more pair of wheels because this is very tedious. There we go, that one worked first try. Now I'm going to constrain these faces. Oops. Just like that. So the next wheel and the final wheel, because I am very tired of wheels and axles, going to add like that. And now I'm going to connect these faces, and you can imagine that we do this for the entire spinner here. That's what we're going to call it. It's a spinner because this can rotate. And segue, this can rotate thanks to motors and gearboxes. And there are many different types of motors and gearboxes. If you're just a cadder, you probably won't have to worry about that. For this specific mechanism, I'm gonna use a versaplanetary single stage 10-to-1, which sounds very complicated. But it looks like this. It's a gearbox and a motor, which allows this axle right here to spin. So let's say that we wanted this motor to be right here, so it can spin our axle and rotate these wheels. But what we can do is the same exact technique with this axle. We're first going to make a hole, and instead of using a bearing, as you'll see, we're just going to leave it as a regular circular hole, because motors are a pain to deal with. So I'm going to open this part again, and this time I'm going to add a hole all the way down here. And the hole that we need, based on it varies based on your motor, but in our case it's 0.625 inches large in diameter. So 0.625, and I'm going to say this is, let's say, 3 inches from the edge. Finish sketch, intrude that, and you might have to do both semicircles. And now we have the hole right there, so I'm going to save this, X out. And as I said before, we're not going to be using a bearing here because, frankly, in CAD it's not that necessary for stuff like motors. So I'm just going to constrain this circular axis right here to this circular axis. And And yeah, just like that. Now I'm going to bring this all the way so it touches the face. And now you can imagine that when this motor receives power, this part of the axle will spin. And what we can do is attach a pulley on the edge of this axle and a pulley over here. And then we attach a belt in between these axles. So when this motor spins, when it's given power, this axle spins, which means these wheels will spin. As a result, oh, by the way, you'll notice there's a hole over here. That's a bit of a problem. We probably should have used separate parts for these because they're non-symmetrical. But anyway, when this motor spins, if we have a belt running between these axles, this spinner assembly over here will also spin. Now, just as a general note about practices, when you're working with stuff like intakes, this wheel-axle combo is called a spinner or a roller, and you're generally going to want to have that as a separate assembly. I made it right here in this assembly, but that's probably a little less convenient if you need to use the spinner multiple times. So in general, you would create it in a separate assembly and import the assembly into this larger assembly. But for now, that is all. That is our introduction to FRC parts. Hopefully you have a good understanding of a lot of the basic stuff. And we're done.